Hello viewers, in this video we are going to classify some problems if it is under the classification of PDE, if it is what linear, non-linear, quasi-linear or semi-linear partial differential equation. According to what is on the board, classify each of the following partial differential equation as a linear, quasi-linear, non-linear or semi-linear. Also state whether each is homogeneous or not. I've explained linear PDE, I've explained quasi-linear PDE, I've explained nonlinear and semi-linear PDE. So what is homogeneous? When we talk about an homogeneous refers to in an equation, every single terms in a given equation must have the dependent variable or the partial derivative variable. It must contain its dependent variable or its partial derivative, either way, either one. So if I have z if I have z as a in an equation, I must have each terms must have z, or it must have what the partial derivative of that z, which is according to what they were given. And if it is u, it must have u, or it have what the partial derivative of that u, which is what the u. Question 1. Del square z all over the x square plus del square y all over the y square minus 2z is equal to x square. We have to classify this. So let us study the each terms. We have in each term, we have del square z over what the x square, del square z over what the y square, then minus 2z is equal to x square. The order of this is 2. Z is differentiated how many times? The z is differentiated with respect to x 2 times. Then the second term, z is also differentiated with respect to y 2 times. Then the last term is what? The third term is what? 2 is having a what? A z, having a z, 2z, then is equal to x squared. You can see this. Let us now check the order here is 2. The order of this is 2. Because the partial derivative, we take order from the derivative. The order here is 2 because we will differentiate twice. Here is also what 2. So let us now check the degree. The degree here is what? The highest order. So the highest order are 2. So the degree here is 1. The degree here is 1. So whenever we have a degree having the order having a what? Having the degree is 1, we call it a what? A linear PDE. It is a what? Linearly partial differential equation. So this equation is linear partial differential equation. Then let us state about homogeneity. Is it homogeneous or non-homogeneous? This term is having z, this term is having z, this time is having the third time is having z. But this z is having the derivative of z, that is the partial derivative of z. The second time is having the partial derivative of z. Why the third time is having the dependent variable, which is what z. And the last time it does not have either partial derivative of z or dependent variable of z. So the right hand side here does not have what? A partial derivative of z or a dependent variable, which is z. It means it is not homogeneous. Because if I input z, if z is equal to 0, if I put z is equal to 0 here, I'm going to have the square times 0, I'm going to have 0 over the x square. That is 0 plus 0 minus 2 times 0. That is 0 plus 0 minus 0. That is 0 is equal to what? X square. And our z must be what? Must be 0. You can see that we still have what? Another term here, which is what? Last term at the right hand side, which is what? X square is equal to 0. Homogeneous states that each term must have a what? The given partial derivative, the given dependent variable, or its partial derivative for what the dependent variable is given. So due to the x square, the equation is non-homogeneous. So the homogeneity is what? So homogeneity, non-homogeneous, due to x square at right hand side. Second example, the square z over the z, the x, the y is equal to z. So we have to state this. Is it linear, non-linear, semi-linear, or quasi-linear? Let us study the terms. The order is what? The order here is 2. The order is 2, order 2, because it is differentiate twice, and the degree is what? 1. So whenever we have the order, if the power is 1, it is linear PDE. So it is linear PDE. So homogeneity, let us take the homogeneity. The homogeneity, is it homogeneous or non-homogeneous? This is what? Homogeneous. Why? Because first term is containing the partial derivative of the dependent variable, which is the z. Then the second time is having what? Dependent variable. I can take this one to here. Another way I can express this one, I can express this one as del square z over the x del y. Take minus z to the left hand side, minus z is equal to 0. So you can see that this one is the first term is having the partial derivative of z. The second one is having dependent variable of z. So you can see that z is each term having z. So it is homogeneous. So question 3. What type of PDE is this? Let us study the terms. First term, second term, then we have is equal to 0. You can see that the order of the partial derivative is here is 1, the other here is also 1. It makes it to be linear. But we're having coefficient that is multiplying that linear PDE, that is the order of the other one, another one of this partial derivative. Z is multiplying this, while S is multiplying this. Whenever a Z as an dependent variable is multiplying the partial derivative, which is linear, dependent variable is also multiplying the partial derivative, which is linear. We call it a what? Quasi-linear PDE. So it is a quasi-linear partial differential equation. So that's why we have a quasi joined with what? Linear PDE. Let us check the terms. We have Z here as a partial derivative. You can see Z here containing the partial derivative. The second term, we have is X, the Z over the Y, also Z here. So it is homogeneous. You can see if each term must contain is either Z or its partial derivative of that given Z. So this is terms Z and Z is here. So Z, the Z over the S is present, the Z over the Y is present. So it is homogeneous. Because every times here involve what? Z or its derivative. Question 4. 2xy. What type of PDE is this? This is a non-linear partial differential equation. Derivative here is what? Derivative having a power of what? 2. I think the degree is 2. And whenever we have a derivative having the power of more than 1 degree, we call it a what? Non-linear PDE. So it is non-linear PDE. It is non it is non-linear PDE. So let us consider the homogeneity. Is it homogeneous or non-homogeneous? Let us check the terms. The derivative, the given derivative, we have a derivative of the z over the x. Now z, consider this one is containing the derivative, its derivative. This one is containing, the second term is containing dependent variable, which is z. While the last term does not have what? Does not contain its derivative or dependent variable of z. So that makes it to be what? Non-homogeneous. Suppose we have z here or the derivative of that z. This one will be what? Homogeneity. It will be homogeneous. But the last term does not have what? Due to the last term does not have the derivative of that z or dependent variable of z. That makes it to be what? Non-homogeneous. So it is non-homogeneous. Question 5. Del square z. So what type of PD is this? This is a linearity partial differential equation. Why? Because each derivative of z is what? Is having what? The power is 1. The power is 1. So that's why make it to be what? A linear PDE. It is linear PDE. So let us check the homogeneity. Is it homogeneous or non-homogeneous? Let us consider the terms. First term, second term, third term, and last term. Then it's equal to 0. What do we have here? We have a derivative here. Yes. We have a derivative here. And we have a derivative here. But in cos s, it is what? It is what? It is cos sz does not have a derivative of z or dependent variable of z. So that makes it to be what? Non-homogeneous due to what? Cos x. Because if you say z is equal to 0, if you put z is equal to 0, it will be 0 minus 0, 2 times 0, 0 minus 0 plus 0, minus cos s. So it will be minus cos s is equal to 0. So that makes it to be what? Non-homogeneity. That is non-homogeneous. So it is non-homogeneous. It is non-homogeneous due to cos s. So the cos s term. So number 6 question. Di z over di x. One, you should state this one. Is it linear, non-linear? Is it semi-linear? Is it quasi-linear? So let us open this one. For us to consider this, let us open the terms inside the embedded with the bracket. Di z over the x times 1. I'm going to have di z all over the x plus multiply these terms, the derivative multiply with this. I'm going to have di square z all over what? The x, the y, then it's equal to, what do we have here? The square z all over what? The y square. So I have opened this bracket. This is what we have. This gave me this. So what do you have there? So let us now consider the terms. Let us check the given terms. How are we going to classify it? So this one is first derivative. This is the derivative. Here is the derivatives. But this the order is what? The derivative here is what? The order is 1. The order of this one is what? 2. The order of this one is 2. That is, it was differentiated 2 times. The highest order here is 2. But let us now consider the degree, the power to it. So it is power of 1, power of 1, power of 1. And non-linear means the highest order degree must be what? 2. You can see that the highest degree is not 2. So the power of here is 1, the power of here is 1, the power of here is 1. And it must be in first degree, which is what? Linear. So let us now consider semi-linear. Semi-linear is what? The linearity PDE must what? Must have a function of what? The z over the y multiplying with independent variable of x. So it is a semi-linear PDE. Why is it a semi-linear? Because the highest order derivative, the square z over the x dy, is what? Is perfectly linear with a constant coefficient. Semi-linear PDE. It is semi-linear PDE. I cannot classify this one as non-linear. So semi-linear state that we have to check our derivative. The linear, that is the other one, the power must be 1. So it means the power here is 1, the power here is 1, the power is here. It is a linear PDE. But we're having the square z over the s. So when you want to check it, the highest order. So the highest order here must be linearity. So the reason why this is semi-linear is that the highest order partial derivative here must be linearly. So the linearly is what? It means the highest order here is 2, which is what? Power of 1 is 1. So, and must multiply with what? The coefficient of what? Z, the coefficient of what? X and Y. So that's why we have this one as what? As what? As semi-linear. Suppose it is multiplied with what? Z here or another X here. We have what? Independent and dependent variable. We classify it as what? quasi-linear. So it is a semi-linear PDE. Number 7 question is equal to 0. You can see this. The order of the partial derivative here is 1. 1. So open this bracket. What are we going to have? I'm going to have sine dz all over ds multiplied by this. I'm going to have d squared z over the x squared plus dz over dy is equal to exponential s minus exponential x is equal to 0. What type of partial differential, what type of classification of PDE is this? It is what? It is non-linear PDE. Why is it a non-linear PDE? Because of what? Because we have something outside multiplying that derivative, which is what? Sine. If I want to classify this as a degree, what is the degree of this equation? The degree of this equation is what? It is undefined due to what? The what? Because of the trigonometric function is multiplying the what? The trigonometric function is multiplying what? The derivative. So whenever a trigonometric function is multiplying a derivative, we will classify the degree as what? Undefined. But since because of this sign that is multiplying that derivative, that is if they are multiplied together, if the derivative is multiplied by sign, we classify it as a non-linear and the power to it must be what? Must be more than 1, occur as 2. So it is non-linear. It is non-linear. Then it is what? What is the homogeneity? It is non-homogeneous. It is non-homogeneous. Non-homogeneous. Due to exponential x term. You can see that exponential s is not having a derivative of z or partial derivative of z, which is what the z over with respect to that value. So it is what? Non-homogeneous. Number question 8. This question 8 is a question related to this. You can see the power, the highest order here is what? 2. The highest order here is 2. So the power is what? The power degree here is 1. So it is a what? It is a linear PDE. It is a linear. And let us check if it is homogeneous. Because if we have is equal to 0, we have first term is having z derivative, second time is having derivative of the given z, which is dependent variable. Third time is having the derivative of z. Then the last time is having the partial derivative, which is z. So it is homogeneous. It is homogeneous because every terms contain the derivative of z and its dependent variable, which is z. Question 9. So the z of 2 is equal to the square z all over the x dy. So what type of PDE is this? Classification of PDE. It is a semi-linear. Why is it a semi-linear? Because of what? We only consider the linear equation there, which is what? All over the x plus the z over the y. This power of 2 is equal to the square z all over what? The x, the y. If you have a coefficient, which is what? Independent variable x or y is multiplied. X and y are multiplied together, and it is a what? It's a linear PDE, which is what? 1. You can see from here as well. We call this one as a semi-linear because of what? The z, the y are multiplied together. The coefficient, the z over the y are multiplied together. And also, what do you have here? The z over the y are multiplied together. And the power to this, the square z over the x, the y is what? 1, which is what? That make it linear. So this equation is a semi-linear PDE and it is homogeneous. Why? Because of each terms contain the partial derivative of what? Z. You have a partial derivative of z, partial derivative of z, partial derivative of z, which make the equation to be what? Homogeneous. I hope you find it interesting. Don't forget to subscribe to my channel and share to others. Thanks for watching.